of a system, that needs to be, I would say, the ratio of center of gravity has to be optimal. So the same way we do have our center of gravity of our body, the same way this frames would have a center of gravity. That center of gravity has to be as low as possible in order to get better ride handling and stability. So I'll be discussing more on that when I go through. So yeah, so this is a small first intro about this electric vehicle frame. So these are the types of frames. And when I told that you could play with a frame of an electric vehicle, that's because it is because of three factors. One is you don't have the huge size of the engine and an exhaust. So because engine itself now when you are removing an engine, when you are removing an IC engine based vehicle, so these are the components that you remove. First would be the fuel tank. Second would be the carburetor system. I mean, which is again combined with the engine only, but I'll go with the engine only. So engine and the carburetor system. Then I will go with the battery, that 9 volts battery or the 12 volts battery that we use in the system, the vehicle part. That is another component that you would be removing. And the last one would be the exhaust system. So these are the main four key components that you remove from your IC engine based vehicle. So what happens is it takes sort of like, for example, if I have to give you a small example, for example, a KTM 390 or like for example Yamaha YZF, Yamaha R15's engine weighs around 46 to 50 kgs. The whole bike is around 135 odd kgs. So it's just some like approximate numbers. But engine accounts for 1/3 of only engine accounts for 1/3 of the weight. And also you have you also have exhaust system, fuel tank, then you have uh, battery, additional battery and all. And to accommodate all this, you need a rigidity in the frame, because when you don't have that rigidity, this frame might that around that center of gravity point. So there is a center of gravity point that I'll be discussing more on it. But so around that center of gravity point, the whole system breaks off because of this unable to withstand these stresses. So that important the frame is. And with removing all this external stresses, like whatever we have discussed about the engine based stresses. So when you are removing all these stresses, you are left with an electric motor uh, that pulls your wheels. I mean, like the same way with the engine, but you are cutting down the weight by almost, like I would say, uh, the same. If I have to compare with a Yamaha R15 or a KTM 390, I'm giving you a small example for motorcycles, because that's more much with the weight thing that we can accommodate. So the same, to achieve same torque of KTM 390, if I have to replace your engine with a motor, the motor would be weighing around 4 to 5 kgs, but the engine itself weighs more than 35 kgs. So I would say there is a drastic reduction in the weight. Now again, so first thing is that we have decreased the weight. I'll just show you a small example, like this structure here. The round circular one is the motor part. So let's break it down. So now we have removed engine. So first thing is I have removed the engine weight. Then now I am putting a motor. So my weight is almost decreased by at least 60 to 70%. Now second part is engine has like close to, like what we have discussed in the bikes, is close to 20, 25 or 30 odd moving parts. But let's come to electric motor. We only have 4 to 5 moving components. So what happens is, you don't now again, what is the direction of the force is another important factor, I would say. Like in engine, you're all aware of this reciprocating motion. So the reciprocating motion would be in the up and down thing. And what happens is you are creating an inertial mass in the up and down way. So your CG affects every time your piston goes up. So there are a lot of such factors. So I'm just giving you a small example with the CG and reciprocation. But the reciprocation is affecting the whole frame structure in the up and down motion. But now what is the forces that an electric motor has? Because we are talking about a rotary motion. It's a basic mechanism run through like electromagnetic force, and your shaft rotates, and your stator has a magnet, which I'll be showing anyways, but I'm just giving you a brief. So it's just a rotary motion. So rotary motion, what it creates is it only creates it doesn't create you in forces up and down motion, or rather horizontal way, much of a horizontal way. So what happens is it is actually reducing your inertial mass as well. So you have the rest mass, you have the inertial mass being decreased. So you have cut down almost like 60 to 70% of the vehicle weight, like engine weight. Sorry. Then coming to battery part. Now what exactly? How does battery and engine combine? I mean, like, how do you compare the weight of the battery and the engine? Like as I was telling, to attain a power of, for example, to attain a power of what KTM 390 does. I'm giving a small example. So the battery requirement would be around 11 kgs. So this was already proven. So I mean, like so what I would say is around 15 kgs of battery and motor, but alone 35 to 40 kgs of engine mass. So that is only the rest mass. So imagine you are cutting down only the engine, only taking out the engine part, you're cutting down almost like 30 to 40% of the weight, because you're comparing 50 to 40 kgs. So, and you have inertial mass that comes additional with an engine, which is like which accounts for a 15% at least. Then you have exhaust, battery, other components as discussed before. So here the only requirement would be a battery and a motor. So this reduction in the weight drives the need for the change in the frame. So you don't need a bigger frame. I mean, you don't need a frame that has the same rigidity as a frame of an IC engine. So this decrease of weight of the components that is stored in the frame also drives the decrease in the weight of the frame. So that is the reason you need a change in the frame. Again, as I told, there is no need for change in the suspension, because I mean you definitely need a suspension for a good ride. What changes in the suspension system would be the spring stiffness. You do have a rear suspension with a spring, right? So that spring stiffness would be lesser because the weight of the system is much lesser comparatively to the IC engine frame. So this is how the components change. But so let's not discuss much about suspension, front suspension and the rear, because those are not going to affect much. It's the change in the value of the spring, which again needs to be. I mean, it is just a small calculation as we do learn in the I mean, like during our curriculum only. Again, a small analysis would help us to achieve that. So comparing these two, what I said, the only discussion would be cut down to the frame. Now, now I'll be discussing about different types of frames in the electric vehicle, and tell you how many variations that we could see in an electric vehicle frame, which are not really possible in an IC engine part. So this is a typical tubular frame. You could see these kind of frames in Activa or TVS Jupiter or something, like any of the scooter companies. It's almost the same. The structure, the way it looks is same. You could say, again, it comes down to the basic mechanics. What happens is you have to choose a dimensions of the pipe that actually, how much you're bending stress. Because if you could see the whole weight in this image, the whole weight is centered near to the center. What happens is, uh, I really wanted to show a demonstration, but I really will tell you in this way. Like for example, if you could see the component, if you Sajid, Is my if I'm moving my mouse, is it pointing towards something, or there is no indication of mouse only?
Yes, sir, your mouse is not visible.
Okay. So okay, I'll indicate the component number so that you could really focus on why I'll be focusing on. So if you could see the component number 11, it's a uh, long tube that is at the top. So that is where your front suspension sits in. And if you could see the point number like 27 or like 52, something near that, that is the whole electric motor and the controller system. And near 32 and 33 is somewhere your rear suspension sits and swing arm sits in. So what happens is, at the center, like I'm talking about a position of 14 and 13. So at that part, you are having a stresses from both the directions. Like front front creates a clockwise kind of forces, and rear creates a anti-clockwise kind of movements. I hope you got my point. So at 11, when you are going on a speed breaker or any kind of bumper, what happens is it pushes your suspension in the upwards direction. So the force experienced at 11 would be a clockwise kind of force. And when you cross that bumper, or when you are at the same thing, when you are crossing your rear wheel, it again pushes your wheel upwards direction. So, but being in opposite direction, what it does is it creates a movement, bending movement, like it's a clockwise and counterclockwise direction, and which the major force would be stressed at the center point, I would say, near 14 and 13. So this is how you analyze the frame basically. And depending on and also other components as well, where you have motor and battery. So all this combined together, because they even take the structural loads, what happens is you have to decide your pipe dia, because you are here using tubes and pipes to build your frame. It's a tubular framing, and you use tubes to build the frame, join it, bend it and join it through welding. So this structure depends on the external forces are common for both IC engine vehicles and electric vehicles. Nothing's gonna change. The only thing changes is the internal components. So that's where this whole, the additional weight removal and all these components, where the force is stressed at this point, that is where your key design has to lie in. And also your suspension has to take the most of the forces. But the force, I'm just trying to give you a moment of how the forces act. And here I mean, like at the point number 11, the most of the forces are damped because of the suspension. And at point number 32 and 33, most of the forces are damped again because of the another suspension. So then again, your frame takes some structure. Your frame also has structural rigidity, which also takes the forces from the ground. So that is where the frame analysis comes in. And because you don't have an engine right now, you're not focusing on you need not focus on the components inside the frame. So it's just that you really have to worry about the motor mounting and the amount of torque that it generates, and the how much torque it generates, and how with what torque it pulls the wheels. So these are the key factors that you need to focus when you're designing an electric vehicle frame. And I would say comparatively, electric vehicles frame comparative to the IC engine frame would be at least like I would say like 30 to 20%, 30 to 40% less weight. So I would say like if an IC engine would be around 30-40 kgs, this would be around 22 like 22 kgs, 20 kgs or 20 odd kgs. So that is how much is the variation in the frames, and that is how this is the only component that is being impacted by change in the IC engines. I mean, there are other factors you can always play with, changing the wheels, changing the suspensions because you have less weight. But yeah, it again comes down to how much optimization that you wanted to do and how better the ride you wanted to give. Yeah. So I would talk about the first thing, basically aluminum frame. So aluminum frame, basically you could see aluminum is being used, and I would also recall a small our previous session where we have discussed about the frame that we have used. So these are made mostly out of casting. You could always have a chance to use sheet metals being bent and welded. Casting is one process. There is, we have learned it in the first year, obviously, like, welding, though it is a permanent joint, weld stresses are also there. So there is always an impact on the weld area, because of these external forces. So another key factor that I actually wanted to discuss is lesser the amount of joints in the frame, more the rigidity in the frame. So because those points that are being jointed to the main frame or a subsystem of the frame, what happens is that at that joint you have these external forces continuously acting. So you could say there is this terminology. I mean, like, and also you could say that there's a weak point in the stress. So weak point in the frame. So that weak point has to be definitely avoided as much as possible. So that's the reason. Uh, that's the reason you go with the singular frames, basically. I mean, like, try to avoid as much as wells as possible. So to give you a small example, what we have done in our our second model, it's not the aluminum frame I'm talking about. It's a tubular frame where you have seen. What we have done is the whole frame was designed. I mean, like, to accommodate to designed in such a way that it only requires three welds overall. So basically, the whole I would say the whole structure of the body, I mean, like, the whole structure of the vehicle is joined only by three wheels, which is like kind of the least you find it in automotive structures. And see, what we have tried to do is use different manufacturing process, like bending, bending the tubes in such a way that you don't require a lot of joints in that. And to be frank, like, I'll put you in this way: we have used 12 planes, 12 different planes. I mean, if you're taking only in the XY XY thing, so it's a complex frame. I would say, like, the key again comes down to manufacturing. So I was also talking about manufacturability. So you have three aspects in every product. Again, I'll just brush it up. So design and manufacturing are the two ends, but what key thing lies in the middle is design for manufacturing. So to give you an example, if you follow more of an automotive news, you would see like BMW releasing an iVision car, or Audi releasing an concept car, Apple releasing a concept car. So this what concept car means is that it doesn't really have a capability to go into production. So it is just that it is just being made to show that this is our I mean the design capability of the companies. So you could see like various sleeves and various curves in those cars, but the real manufacturability is not possible because of the material constraints or manufacturing machinery constraints or any kind of things. So uh, the key thing here to learn about frames, electric vehicles, frames, and manufacturing. See, I wouldn't have much focused same as suspensions or tires. I would have left it out the manufacturing part. But the reason why I'm focusing here is you do really have a choice with electric vehicles. But with IC engines, it's always the space constraints, and to accommodate all those components, it really is a key challenge. But with electric vehicles, I don't say it's not a challenge, but it's more with IC engines, it's a challenge, and with electric vehicles, it's innovation. So if you are seeing what I tell you is, if you are seeing a normal scooters or normal electric scooters, uh, I mean normal school, I mean electric vehicles with scooters design, it's not like there is not much of it's like there is not much of innovation there, because as I told you the factors here, there's a lot you can play with. There are like quite a good companies in India that have come up with a different unique designs in the frames. like I mean, like you have to name a few. I mean, like, but that is where when you have everything to play, innovation comes into picture. Like if you could see, we have seen this aluminum monocoque, aluminum frame made of casting. So this has like you wouldn't need an extra welding, or you wouldn't need an extra component to fit in. Like the bottom point is where the battery sits in, and the point where the swing arm is there, the end points near the swing arm, that is where the motor fits, and you're done with the vehicle part. So there is nothing addition, and that's how simple the frames are. And aluminum, we haven't discussed. There is no discussion in the automotive industry about aluminum frames so far. I mean, until electric vehicles have come in. So we have always been using the steel-based frames because of the rigidity and the bending things that they always provide. And obviously, aluminum are highly priced. That is another key factor again. So there is something that we need not really get into. So again, I'll be discussing about the last part of the frame types and how these things are. Like, this is a complete monocoque frame. So the same way I told that the aluminum is being manufactured as a single unit, though here you could see that certain components like, the rear swing arm has to be attached or welded in such a way. But when it comes to monocoque frame, everything is made as a single unit. So it's like, one second, sorry. So everything is made as a single unit. Now, if you could see that this structure is completely carbon fiber based. So you must be knowing like how this type of manufacturing is. It's like, mold making. So initially you make the mold out of this design, and then you take the components out. The same with the casting, obviously, but this is most of a like glass fiber involves hand molding. But this is completely involved with carbon fiber. So carbon fiber, as discussed in our early sessions, carbon fiber is one of the most the material with highest strength, or it suits more of an automotive applications and drone applications. So what it does is, it gives you a lot of rigidity that is required for an that is required for any two-wheeler, I would say. Preferably electric two-wheeler because of the non-reciprocating forces available in the, inside the frame. So that is one thing. And just what happens to this monocoque frame is the stresses are equally distributed. The same advantage with aluminum frame and this monocoque frame is that the stresses are equally distributed. You don't have joints. And as discussed before, those external forces won't really affect the frames. The rigidity of the structure. So this is about the types of frames, as I told, this monocoque, aluminum, tubular frame. So, and you could, in tubular only, there are different types of frames, which I won't be going through because I just wanted to highlight the importance of the frames, not the discussion about frames. So as I told, like, when you really want to make an electric vehicles, like be it as a wanted to try it at as a project, as an innovation, you could also, the innovation factor also lies in frames. So that is one point I actually wanted to highlight. It's not only to motor and battery, it is also the innovation in the frames. So these are the different types of frames and the effects that it has on an electric vehicle. I'll just run you through what are the simple other factors that actually affect any kind of frame. But typically, when we are discussing electric vehicles, this has a lot of factors because electric vehicles are really, as I told, less components. So less components. You can accommodate more all these components in a small place. So when I told CG, so you all know about the concept of CG, right? So center of gravity. So center of gravity, it's a basic physics. I would run you down for a minute. So gravity always pulls you down. So again, so interrelating these two, that's it. That's the only key point behind this. So the lesser the center of gravity, I mean, I'm not saying only the gravity affects this CG point. There are a lot of other factors like bending moments, uh, but more in a physics point of view, I would say it's more of a the more and more the weight at the bottom, the less is the chance of toppling away. This toppling usually comes in cars, but what I say is more is the stability because you have lots of weight at the bottom, and you know that bending moment. I mean, like bending moment is nothing but like uh, some force into some radial distance, right? So what I mean is there is 2 points called CG and another any in any two-wheeler or four-wheeler frame. There is this thing called CG and another point is called bending moment point. So these 2 points, the distance between these 2 points has to be as low as possible because these at CG acts as a pivotal point of rotation. So, for example, the one in the picture, I would say, consider the bottom point of the frame as CG point and top point of the frame as a bending moment point. So what happens is CG point acts as a bending moment point. Sorry, CG point acts as a pivotal point. The distance between CG point and bending point would be the rotation across that. So to achieve less to achieve less kind of this disturbance, what you have to do is design the whole frame according to your components. It's like when you have battery and motor in a lesser dimension. I'm showing you my frame itself again. So here, if you could see in the near the motor and battery accommodated at one place, what happened is, 1 second. I'm sorry. Yeah, sorry. So what happened here is, you have everything you see the same way, like here. Uh, so basic. I'm sorry, I missed few points. Uh, so yeah, the point is here, the more lesser the vehicle. I mean, like the whole weight is towards the ground or towards the bottom part of the vehicle, the higher is the stability. Uh, because when you're this helps basically in maneuverability. I mean, straight line motion, there is absolutely no problem because straight line motion you are already comfortable with inertia of both your when you are attaining certain speed, your wheel inertia is already conserved. Angular moment of inertia is always conserved. So I mean, like angular momentum is conserved basically with both the wheels, and it actually gives you a complete stability to the vehicle at higher speeds. What focus would be is more on the lower speeds. But do we really need to discuss about lower speeds? I would say absolutely, because 80% of the travel we do with two-wheelers is in the cities itself. So what happens is when you are cornering or when you are when you are having this difference in the center of gravity and bending moment, bending moment point, what happens is it doesn't give you a proper ride in the cities. Like when you're going through bumpers or different roads, it doesn't give you a ride stability. It always tries to jump up. So that is how this CG affects the whole electric vehicle frames or any kind of frame. But to be specific in electric vehicles, because as I told, the components would come down definitely. So this is much about the two-wheelers. As I informed, there is no change in the dynamics of the system. You could use a different, lesser suspension effects, lesser spring strengths, and higher brakes, obviously because of the high performance of the vehicle. So yeah, these are the factors that affect frame because of the motor and the battery replacing the engine. So I hope we are clear. But I'll just continue with the four-wheeler frame also, so that before taking questions, we'll finish off. Yeah, so I was mentioning about four-wheeler frame from the right away from the first discussion. I mean, during our second session. So the four-wheeler frame here, you could see that the bottom part, the bottom part that's in the middle is the battery part. So that is where the whole battery is there. Now, when I told that CG doesn't much affect this electric two-wheeler, it does affect the four-wheelers actually. The for four-wheelers, lesser the CG, I mean, higher would be the stability. It's a very basic thumb rule, I would say. You know, more the higher the points of the CG, when you're cornering, there is the high chance of toppling, the four-wheeler being toppled. So these are this is how the CG affects. But I would say like the reason why I have only picked up this part is this is where the key frame lies in. You know, uh, for a engine based car, also even the frame looks similarly. But what happens here is we are putting the whole structure. Like you could see the front part, the middle part, and the rear part. Rear part contains differential. Front part contains steering. The middle part contains battery. So you could see that whole system is as much as lowered as possible. So it's towards the ground, and the CG is as low as possible. So that is where your structural integrity comes. I mean, like the ride integrity comes. There is when you're cornering, there won't be much difficulty while cornering. Even at higher speeds, you can corner very easily. Now, talking about the last part of it, we've always discussed about steering motor being at the center. Now, if I have to have a four-wheel drive, I need to implement a system over here also in the front part also, and I need to have again a differential based mechanism because I mean like though you have a steering there obviously, so there is a real challenge. So there is something called a modular frame. This modular frames have become the future of the four-wheeler technology, four-wheeler electric vehicles technology. To discuss more about that, what I would do is like uh, here I'll go back to this picture. So you have a motor at the center. Please try to focus on the rear part of it. So the rear part at the center is where you have the motor and the gearbox system, and there is a whole differential system lying there. So that is how a conventional two-wheel drive does for an electric vehicle. But with a modular frame, what happens is you have motor. Now you have all the systems in the tire near to the tire itself. I would say at the tire itself. So this happens when you want to build a modular frame. So I would again go back and say like the key challenge here in the frames modular frame here is like uh, the key challenge in the normal frame is you have the problem is you have a limited, I mean like you have a constrained wheelbase, and the rear space of the vehicle, like the motor and the differential, is quite occupied. But here if you could see, I'm sorry, or if you could see that the left side of the picture where it is shown that like there is a 33% weight reduction. What happens is you are building you can build any structure on that frame, but not the case with the previous frame. So you call it a skateboard chassis. Skateboard, and like the bottom part of it only is constant. You can put a truck, you can put a car, you can put a sedan, you can put a hatchback or SUV. Because the picture is not in the top view, but I'll go back here. In the modular platform, the middle part where the battery sits is completely, it's kind of a modular mechanism. It could get down your wheelbase. It could increase your wheelbase according to the requirement. For example, if it's a pickup truck or a truck, your wheelbase is much highly required. Or if you're talking about city-based trucks, like what we see in like in our like Tata A's or pickup trucks, small pickup trucks, that's where you require a small wheelbase. And again, the same platform can be used for sedans or a hatchback, because the wheelbase it has a capability to come down. So this is how the modular frames are. This is the advanced technology that is coming in. If I have to pick up if I have to really focus on like what are the technologies that are being in uh, that it is always frame. I mean like it is always in a modular frame, and and also the lower CG part, and also this aluminum frame. So monocoques have been always there with the cars, but aluminum frame is something that has come up with the two-wheeler. So aluminum frame and the modular frames are the future of this frame related technology. And uh, so yeah, so these are the two things, and here ends my small description about the frames. Any questions? You can just shoot me. So I'll just I mean brief it down once more, and so that accordingly we can whether see to proceed forward, or any questions we'll take it now. So basically, as I told, when you're comparing with an IC engine and electric vehicles, it all comes down to the weight part of it. So when you're removing an engine and the components related to it, you are continuously cutting down the weight by at least 30 to 40%. And I mean 60 to 70%, but addition of this motor and battery would bring it to 30 to 40% down. And second factor, the weight, the rest mass is one factor. Second factor is inertial mass, because you have a reciprocating forces operating on an IC based engine, but which is a rotary based, which does not really affect the frame structural rigidity in an electric vehicle's part. And third part is like we have really seen different types of frames. Like, the reason for studying, the reason for going into different types of frame is I really wanted to highlight the innovation part. Like, if I have, like, as I mentioned, with IC engines, it always has to be the structural rigidity. I mean, you do require structural rigidity in EVs also, but comparatively the requirement is quite less. First factor. Second would be, it would always be, you know because of those forces, you really have to have a bulky frame. With EVs, it's always about innovation, how well you can design a compact frame or a lightweight based frame. So that's where we have discussed about aluminium. Sorry, we have discussed about aluminium frame, and the other key factor is the CG affecting it. And the final key highlight would be the modular frame. So with 2WD, you can always mount two motors at the rear, and you can always build a frame of your choice. So the top frame remains always the same. So yeah, this is the outline about the frame and vehicle dynamics, I would say, because as I told, as I was mentioning about the key vehicle dynamics involved in this part, the bending moment part and all. So not much of a change comparatively, but the change in the internal structure would definitely affect it, and you could have a less stiffer suspensions, and tires also, and the same effect on tires and also. So this is an outline of the complete frame and the vehicle dynamics part of it. So yeah, any questions? I would be really ready to take it.
Good afternoon, bro.
Yeah, yes, sir.
Can the modular frame used for normal cars or only for electrical vehicles?
Uh, the issue with modularity comes. I mean, the challenge with modularity with IC engines is, again, the drive system plays a key role. That drive you if you I'll just take you to a small picture of it. You know, the drive system of an IC engine vehicle wouldn't look this simpler. It's actually, you do have a shaft drive also, right? So shaft drive covers from front part of the engine to the rear part. That is first thing where it actually creates a lot of mess over there. And second thing is, like, you do need to have a differential, definitely, for an engine based vehicles, because the rear wheels would definitely create a problem with the torque change in the torque. So if you're talking about a modular frame here in the left side of the image, you don't have a, I mean, like, because it is driven by individual motors, the control system of this individual motors is coded, or like you could say done in such a way that whenever there is a corner, it detects the motion in the wheels, and more power is being generated on the left side of the wheel, when you're taking a right corner. So that's how it eliminates the need for differential. But when you're talking about an IC engine frame, the first key part that obstructs the modular frame is the differential, and second is the drive system, and also the front part obviously won't be able to accommodate. So yeah, that there lies the key part. Yeah.
Like it's simpler the structure and complex the mechanism. Like
Yeah, like for IC engines, it's complicated structure. Here, what you do is, as I mentioned clearly, the center part where the battery occupies, that is where you have a modularity. I mean, there is a chance that you can increase the wheelbase. So, like for example, you already know about difference between hatchback and a sedan. So sedan's wheelbase is quite higher. SUVs is more higher. At this place is where the whole modular mechanism lies in. I mean, extending the wheelbase, but the core part of the technology lies in the wheels. So as I told, like the suspension, drivetrain, everything is being put in the wheels itself. So that's the reason it is called a skateboard, because uh, it has like a very minimal thickness. You could see from this view, it's a very minimal thickness that it has, uh, and which is not practically possible with IC engines.
yes, thank you, bro.
Yeah. I think someone's having a doubt here.
Hello, brother.
Yeah.
You have said that in two-wheelers, while we remove normal combustion engine and replace electrical motor and battery, the vehicle gets lighter. But I have seen some videos in case of cars where the cars gone much more weight, much more gained weight rather than the normal combustion car.
Cars. You're talking about cars, right?
Yeah.
See, with the cars, it always comes down to two factors. So again, I really forgot. Yeah, good thing that you have raised this point. Let's do this thing, like how we broke down the. I mean, like two-wheeler components. Let's break it down in the four-wheeler also. That would give us where exactly the weight decrease would be and where the addition would be, right? So let's put it down. So, for example, if you're talking about a four-wheeler, what are the key components? Like in an IC engine vehicle, you would remove a complete engine part, then again radiator part. Second, the third thing would be a drive system completely. Fourth thing would be a gearbox, and the final thing is differential. So consider you are removing all these components. Now I'll similarly break down. Now I'll put I'll put electric part into this. What I'll have to put is, most of the you are aware of this thing, right? In this cars now currently we do. I mean, like have engines at the front. I mean, all those cars that we have now currently has engines at the front. So now when you're putting an electric vehicle, what happens is the whole front place becomes completely empty, because you have nothing to store there. I mean, like you have nothing to mount there. So my thing is, I can reduce the structural rigidity over there, because I'm not like either I could say mounting or hanging something there. So nothing is being put there. So that is the first thing. And second thing is, when I could accommodate the differential. I won't be removing, because I need a differential and a motor combined in the electric vehicle cars. So there would be a slight addition in the increase in the differential part, because there is a motor always adding up. So that is the first addition that we have. And the second thing is that we are adding a battery. Now it comes down to what battery that we are using. Now, what kind of battery and how much is the capacity? As I told previously, you could build a, I mean, like I can build a 5,000 kilometers vehicle or a 2,000 kilometers vehicle. It all comes down to me. I mean, whether I'm using a battery with a more efficient, I mean, like building a more efficient battery that is giving a higher range, higher mileage, or I'll just keep on stacking the cells until I achieve the range. So there's always a two-way. Like, you could always add more and more weight with adding more and more batteries and improving the range, which is again the graph. If you could take a graph of it, the graph would be, the linearity of the graph would be very much less, because as long as you are increasing the battery weight, you're also increasing the, I mean, like you're also increasing the load, which is like affecting the overall mileage of the system. So certain systems are there. There are definitely people who are building out with a different applications, but I would say never the case where an IC engine is lesser weight. I mean, it has a lesser weight and than a typical battery-based vehicle. You could take an easy example with Tesla. That is how, as I told, I can take a point from a two-wheeler frames. I can easily replace my existing IC engine with an electric vehicle. Just remove the engine and put the electric vehicle components. It doesn't give me the same range, same mileage. It's because it has to drive a larger weight now. I mean, I'm not saying that it will give me some range, but comparatively, when I design a new frame with the only requirements of the existing components, it would give me a comparatively 20 to 25 to 30% of the additional ranges. So yeah, you could take a good example from Tesla as well. So Tesla uses aluminium in most of the components, like and they have the most highest safety across the globe. Any car wouldn't, I mean, like that doesn't have that amount of safety. But even Tesla has built a car that is lighter than like many of the IC engine based cars. Especially, I mean, given the power comparison, I could say like it could even beat whatever the basic cars that we have in India, like Hyundai-Ion or like i10 or something like that. So there is always a way. Depends on whether you wanted to increase the battery range or build an efficient system to have a good range. So it's according to the, I mean, like the companies that they actually wanted to build.
Thank you, brother.
Yeah.
You can continue the session.
Just if you can just give me like 10 minutes, what I'll do is I'll bring all the components. So given that we don't have enough time, we can discuss the drivetrain part, the powertrain part, which is the final part of the session, with components visualization, because that will give you a much clarity to all the people who are in this thing. Just give me like 5 to 7 minutes. I'll finish it up. I'll bring the components.
Yes, Anna. Sure, Anna.
Yeah.
Okay, Harsha.
Yeah.
No problem. Starting.
Yes, sir.
During this time, I am posting the feedback from into this group and also WhatsApp. Okay, you can send the details to the students. What you
Yes,
have to follow the rules and regulations. How to send the feedback form after filling. You can send the details what I have sent to you. Okay. Now I am
Guys,
sending.
sir is going to post the feedback document in a docs form. Guys, you need to fill the document in a typed way or in a written way, and you need to insert the digital signature of your. You need to fill all the details according to that, and you need to answer all the questions which are there in the feedback form. It should be mailed to our domain mail mesa@kitsw.ac.in. That was shared to you in the WhatsApp group, and also will be sharing in the Teams chat channel. Guys, once you filled this feedback form, so that we will be verifying this, and so that your certificate will be generated if the feedback form is filled. And if you have sent a mail to mesa@kidsw.ac.in, so that will be a confirmation that you have attended the session, and also we are downloading the attendance of the workshop, so that two confirmations for your attendance, and this feedback will definitely help us to conduct further workshops or further event. I request all of you to fill the feedback form once the workshop has been completed. You will be given 2 days time. At the end of 29th, you need to submit. Before 29th, you need to submit the feedback form. I think I'm
Yes,
clear.
Satvik, send the email to the in chat box.
Yes,
Send the
sir.
email to the chat in the chat box.
Guys, you can mail to mesa@kidsw.ac.in. I'm texting it in chat box. And we'll be also sharing this information through WhatsApp. Please note it down, guys, so that the certificates and further reference, whatever the thing, will be generated once you have filled this feedback form. Thank you, guys. And the session will be continuing within 5 minutes, so that you will have some, even though it's online, so we'll be having some visualization components, the powertrain, which consists of motors, and the windings will be shown by our guest lecturer. Thank you, guys.
So yeah, I'll be first. So we have discussed about the basically. Hello, sir. Any interruption? Like anything? You have any questions previously? Satvik, should I proceed with the next?
Yes, and you can proceed, Anna.
Sure. Yeah. So, as discussed like previously, like we have covered like basically frame. We have been discussing about the motor and the battery on an external basis. Like we never went into what happens with the motor And what happens with the battery? How does a battery look on a, like, we haven't seen, like, this thing, the like lithium-ion cells. Just give me a second. Sorry for that. Yeah. So basically, as I was telling about, like, but we haven't gone in depth about what is exactly with the battery and the BMS part of it. So again, the motors and motor drives and everything. So I won't be discussing much about motor drives because you're already aware of the drive systems, especially like chain drive, belt drive, and shaft drive. And yeah, so there's nothing much to discuss. It's always it's the same for an IC engine and an electric vehicle. But I'll go a little depth into an electric vehicle and the battery types. So little battery types, battery perform, how does a battery look, and what are the different available technologies now, and how exactly is a battery cell and everything. And finally, I'll touch down with an IoT part. Like, I'll just give a brief about IoT part in the final thing, so which should end our session. Okay. Yeah. So before really going into physical parts of it, I'll initially discuss a little theory on, like, motor. Then we can definitely look at the motor build construction and how do we really go and get into the different types of motors and all. So basically, if you can remember, I was telling about the graph between the torque and the vehicle speed. For there's a small graph that actually indicates that what is the difference between an how does the variation of graph and vehicle speed for an IC engine and an electric motor. So this is for a car, obviously, because it's a first gear thing and all. You know about CVTs, right? Continuous variable transmissions, which you can find it in any kind of any kind of scooters, like mostly in like Activa, Jupiters, TVs, Jupiters, etc., etc. So these has continuous variable transmissions, CVTs, or sometimes, like, mostly sometimes only to continuous transmission, like because you don't need to change the transmission segment, like you're not changing any gears or anything with the uh, bikes or scooters. So I'll discuss something about I'll just put the gear system for a aside for a moment, because all the electric vehicles that are being built are without the gear. The only reason is, why do we really use gears, right? We know the basic concept of it, right? Like, for example, you have a small motor. Forget about like engine and the electric drive system, everything. Forget about everything. You have a small servo motor which you have played during robo wars, or which you have used during any kind of like this applications, robo wars or fan sealings and all. So imagine you have a small motor with a shaft outside, and you have so let's discuss about if you are done, if most of or any of you are done with the robo wars. But, like, you just try to put a gear onto the robo wars, like that motor, and then you run the wheel, or you can directly mount it onto the wheel. So there is always a scope, obviously. So what I'm trying to discuss here is gears. So why do we get higher speeds when we are going to fifth gear? Is it like, there are a lot of factors, like, one is that it has, like, the air intake is completely open at that moment. You have a lot of air and fuel combination coming there. And the second thing is, you do have gear ratio. So I hope everyone knows about this gear ratio. So at initial gears, let's put it this way: when you're putting a first gear, what happens is the transmission system shift, or have a gear contact with the, gearbox completely, what happens is the gear ratio between the two gears is quite high. That's because that it is generating more and more torque. And depending on that, you can obviously work on other gears as well. But what happens here in the electrical part is you don't have a gear, because you could easily drive it in a single, without any access to the gear. So the I'll just put it in this way. I'm discussing more about two-wheelers itself, because four-wheelers, it's more of an induction motor. You always combine it to the rear wheels, and there is nothing much to discuss about the shaft part. It always integrates with the differential. It becomes a differential basically. It is not that it is integrated with a differential. Motor becomes a differential in the uh, four-wheelers. Now with two-wheelers, what happens is there are two systems. I haven't really made a slide of it, but it's very easy to imagine. I'll just give a small example. That's the reason I didn't make it up. I've discussed about robo motors, right? For example, what we do is I put a motor with shaft outside directly to the wheel. What happens is it directly rotates the wheel, right? The same way, what hub motors, we call these as hub motors. So the wheel hub and the motor hub is constant. So you are building a motor around the wheel hub. So that is called a hub motor. And I've shown in my previous vehicle isometric image of a drawing that I've put a motor in the midway and the drive system with a belt drive. So there are two ways. So these are the two ways that you do in an electric vehicle, electric two-wheeler specifically. You usually connect it to a rear wheel. The reason being, for a front wheel, what happens why don't you put a front wheel hub motor is? I've mentioned this particular word called unsprung mass. So unsprung mass is that something that is not on the frame. That is something that is everything away from the frame. I mean, the wheels, especially the wheels constituted of unsprung mass, and the rear suspension are constituted of unsprung mass. The rear swing arm also does. So what happens when you put a hub motor in a front wheel? So you all know that when a body is rotating at a pivotal point, angular momentum is conserved. So what happens is, taking this basic physics principle into account, angular momentum of a consider. I'm not really going into structure. I mean, the whether it is a disk or a V. I mean, complete any other different parts, but I'm considering it to be mr square. So you could see that angular momentum is mr square. So what happens is, when you put more amount of mass onto the rotating wheel, what happens, as I told, it's not a rest mass, it is also inertial mass that comes into picture. So this factor, what happens is, it actually does not allow you to steer much, because your angular momentum is conserved in a single direction. So that is the reason you usually don't put hub motors in the front wheel. Now coming back to the rear wheel, so you build this motor around that hub. So that is how what happens is, you don't need a drive system. Now, if you can remember, I was typically mentioning about the efficiency dropping of a four-wheeler, not about two-wheeler, which we couldn't really calculate. But I would say a two-wheeler, I'll discuss about four-wheeler. In a four-wheeler, the engine efficiency usually is 36 to 40%, but what goes to the wheel is just 25%, because of the complications that we have through gearbox, drive system, and drive shaft and the differential. The same applies here as well in the electric vehicle or in any drive system as well. What happens is, when you have a motor in the middle and you have to drive a wheel, you need to connect either through chain system or a bell system or a shaft system. So chain system again itself is a heavy, and bell system has its own complications with the manufacturability, nothing much. It is also a good efficient system. So with hub motor, what happens is, you don't require a drive system. your motor is already in the wheel. Now what happens is when you accelerate, your hub motor is driving your rear wheel. So the design is made in such a way. Yeah, so that is what you call a hub motor. Now coming back to the mid motor is where you mount the motor same like an engine in somewhere in the frame, and you put a chain or belt or any kind of drive system, and this happens. Now the first question comes is like, why don't, like, you could always use a you could always use a hub motor, because it is not involving any moving parts, right? It is not involving much of moving parts. There are two factors I would say which I wouldn't prefer, or preferring them would be, you can definitely use, but at a lower speeds. At higher speeds, these are the factors that really affect it. One is unsprung mass, and second thing is the torque. So what happens is, I'll just give me a second. So able to see this screen?
Yes, Anna.
Yeah, this by isometric view. Yeah, so basically, if you could see in the bike part, so we have built a motor and battery there, and with motor being connected to the wheel by a belt drive. So I'll give you a small example what the difference what it makes. So here the motor torque is something that you have, the torque of the motor, right? So the torque of the motor is considered like 30 Newton meter. Now with a gear system, with a 1:3 gear system, I can achieve a 90 Newton meter torque at the wheel, which is quite high comparative to what you have in, like, I'm not saying that those are very high numbers, because yeah, consider, yeah, something close to that. 90 Newton meter torque at the wheel can drive you like 0 to 40 in like 2 to 3 seconds, like less than 3 seconds. So or less than like 3-4 seconds. So you can play with the torque here, and you can play with the speed here. As I was clearly mentioning about an IoT system that would allow you to control your motor and battery over the phone. This is where such systems can be employed, and it could be really helpful. This is the one system. This is one advantage of mid motor, where you can play with the torque. And second thing is, you won't have an higher unsprung mass, which will provide you a ride stability. So these are the two factors that counter with a hub motor. Now the question is, doesn't hub motor have a good torque? I mean, like, the point is, when I told that you have a limitation with the motor torque, it applies to hub motor as well. When I told I have a mid motor with 30 Newton meter and I'm driving my wheel at 19 Newton meter because of gear ratio. Here, because why do we do that? Why can't we build a directly 19 Newton meter mid motor and just connect it directly to the wheel? The reason being, to build a 90 Newton meter motor, I need a huge amount of space, and that requires a lot of mass. It takes a lot of mass, and it does not fit in my wheel. So the one major, apart from the 2 points I've mentioned, one major constraint is you have limited torque with hub motors. So I mean, this could be one key factor when you're buying a vehicle as well, because hub motor, you could easily differentiate when you see electric vehicles, electric two-wheelers, and the rear wheel part is being covered. You could always say that it's always a hub motor. So you do come across complications with hub motor, because any service related issues you have to any service related to tire, even if you have to replace a tire, it could be a complication. And second thing is, if you have to completely open a motor, it would completely disturb the wheel bearings and all those stuff. So that's how the complications are with hub motor, and these are the efficiency problems. There would be a 5 to 8% of efficiency drop when you are using a belt drive. Consider your efficiency of the motor is 90 to 95%. You end up with having 85 to 80, 82 to 85% of efficiency at the wheel. So that is how the difference it makes. And as we are discussing this key point, this is the reason why electric motors have a higher initial torque. And the second point is uh, electric motors would definitely, if I have to put a race, in electric vehicles would definitely have a edge over the IC engines because of these factors. So yeah, I'll just give a brief about different types of motors. So one is like BLDC, brushless DC motors, and the second is permanent magnet synchronous motor, and uh, and the third thing is induction motor. So mostly, I could say switch reluctance motors are also the new technology are coming up. Induction motors is kind of more of an AC type. You don't prefer these induction motors in the two-wheelers, electric two-wheelers. It's like these occupy a lot of space. The only constraint is it occupies a lot of space. Otherwise, it's well and good because it has a very good like like you don't have to especially it depends on the, I would say, user's perspective, I mean like company's perspective, because you don't have to really work on manufacturing for induction motors. It's quite easy to get them manufactured and the materials are easily available, which is not the case with permanent magnet synchronous motors, and also with the BLDC motors. Again, so if I have to push more often these things, it is only that the change in the the rotors placement, or rotors or stator placement, or a different type of magnets being used, or different type of mechanism being used, or sometimes it is only the controller part. The only controller part changes, but rest of it remains the same. So if BLDC motors are very hugely used in electric vehicles, and also these days PMSM, permanent magnet synchronous motors, are used because of their constant torque. There won't be torque ripples, high and low torque ripples like a sine wave, which sometimes is possible with BLDC motors. And induction motor, again, to be discussed, like it would be more on a it will be more on a four-wheeler application only. So the mechanism of a motor remains the same. It's the electromagnets driving the whole system, and you pass current through this magnets and creates an electromagnetic field, and that's where the whole rotor part runs, and which is connected to the external shaft, which I'll be showing in the video now in a couple of minutes. But this is this is more about the motors. Uh, I'll be discussing more about the motor manufacturing, and because that is where our more mechanical thing is related to. But I'll definitely discuss about the electrical part as well. So yeah, just give me a second. So I've stopped sharing my screen so that I can show you motors. Just give me a second. I hope you could see the screen. Sorry, you could see the motors and all.
Yes, bro. Yes.
Yeah. So just give me a second, I'll explain. Yeah. So basically, this red part, if you can see, I'm pointing out with my uh, pointing out with my pen. So this part is where the windings are. So you usually create a windings using copper. These are copper windings or some, like, these days different types of materials are coming with, and so that is just give me a second. I'll adjust the screen once again. Yeah. So so this is where the windings are, and these are magnets. So this you could see, if you can see this magnets. So these are the magnets uh, that you mount it through the surface. This is an external flange, and this is this black surface you could see. This is the external flange, and this is where the motor, the magnet parts are being mounted. If you could see here, so this is where the magnet parts are being mounted. So the two options there you could go, because you don't want to affect the magnetism property of it. You do actually have a friction fit option. So you just create exact tolerances and friction fit this magnet and the windings thing. So if I could show you this part this way, you could see this wirings over here. These wirings being connected to the whole winding stuff, right? So yeah, as we have discussed the basic principle before, it's like the current is being passed from a battery to this wires and goes into the windings, which creates an electromagnetic field. So which in turn drives the stator. So this combination part is called stator, and then the one I'm showing you right now in the left side of the screen is the stator part. So I've just picked up a sample from this is what the motor that we have built previously, and this is our previous motor. So so this outside part, this is the casing, and this part is called flange. So this is flange, which actually encloses this motor. Now I'll go more deep into the stator part. This stator part is nothing but a combination of, it's just a combination of uh, sorry, yeah. This is the stator part, which is a combination of steel plates, and you have magnets placed here, actually rotating magnets. It's a magnets placed here, which windings and magnets create an electromagnetic field, and which in turn rotates this whole shaft. You could see that this is being the rotation, and this shaft is basically made of a material called EN9, which is usually material used for for hardening purposes and longer lives. EN9. What you do is a basic machining process. You just take the material out, create the grooves around it for just to make the sprocket mount. So I'm sorry. This grooves around that, you machine them using a lathe or a CNC machining. Then what you do is you complete, once you're done with the whole manufacture, creating grooves and surfaces. What you do is you give it to hardening. So what hardening does is it actually increases the material properties, and I would say it's a longer life. And again, I was discussing about the bearings. So these are the bearings that are being used. So here is a one bearing used, and there is one more bearing inside the flange, I would say. So this is a whole shaft system that runs, and you already basically know about the motor mechanism. So yeah, I'll discuss much about the manufacturing of it, as there is nothing much to discuss about. And again, So this part, this is called the motor controller. So it is basically an electronic circuit. I'll be showing you this way. So it's a motor controller built with an aluminum casing inside or outside. So these fins are being put. This is being, well, like you could see that fins. So these fins are being put because to regulate the airflow while this motor controller is being operated. So this is the motor controller made of aluminum casing, because aluminum has a very good heat transfer capability, and it's a bad conductor of electricity as well. So that is the reason you use aluminum casing. And so this is what you know, there are certain things, you know, you are worried, like for example, you are worried about electric vehicles. You know, we anytime must have encountered this, uh, like uh, like we might have got a shock while touching a TV dish bar, or like, you know, tester using testing something or putting it in a circuit, or while you're working on any small projects. So the same way, I mean, even they say that, you know, water, yeah, you know that water is a bad conductor, and that would destroy the whole system, obviously. So this connectors and this whole mechanism is built, and this is an IP67 rated. So what exactly is an IP67 is, like, you know, you have ratings for the certain standards, right? Like for example, your vehicle has to follow certain standards, but they don't really ask you to make it IP67. What IP67 does is, even if you put this motor controller in water, in the surface of the in the depth of the water until 30 minutes, there won't be any single drop of water that would be going in. So the reason why I am specifically mentioning about this IP67 rating is, it all comes down to your mechanical design itself. You know, I'll show you a small circuit here. There's a small circuit. This is the PCB. I mean, this is not the one that goes in, but this is an electronic circuit which is powered up. So when you are powering this electronic circuit, what happens is, every system, every small component, just give me a second. You could see the small components here, small components here itself. Every small component has the same power and all those stuff. So that is the reason when you touch this after you connect it to battery, you would definitely get a shock. Or even this circuit also fails. Sometimes it burns off. I don't remember, we burnt like 10 to 15 such boards developing this. I mean, such kind of circuits. You learn, obviously, but yeah. So that's how complicated the circuits are. And what you do is, this circuit is placed in this box. Now we are really worried about this circuit because I mean, like, I hope you know the difference between AC current and DC current, right? Alternating current and direct current. The one that you get in the household power systems is alternating current, and the one mostly used in electric two-wheelers is direct current, and then most of the other things also use direct currents. 220 volts AC doesn't give you much of shock, or like when you are touching through it, touching it. But any like 12 volts or like 24 volts of an DC current can give you much amount of, like, it gives you a shock because of the current passing through it and all those stuff. AC current is quite different because you have a waves, sine waves, and you sometimes feel the shocks and doesn't really happen. But DC current is it's a different story. So why I'm discussing all this is to focus more on the mechanical designs. What we are more subjected to, what our design capabilities, or what as a mechanical engineer, what challenges we do encounter while developing a component. So that is the key thing I actually wanted to discuss here, because this circuit is always powered, and you don't want water to enter it, because you're all if you're using a steel frame. Anyways, it's not about the steel frame. What it does is, water creates a conductivity, and it damages the whole system of it. So that's where you have to create a waterproofing enclosures. So these are actually IP67 rated. So how do we do that? Because you know that manufacturing is a really challenging job. So you can't rely on manufacturers all the time also when you are sourcing it externally. So even with the small bolts also, when you're putting a bolt, there's always a scope that the small space near that bolts will obviously give a scope to the water entering the water. So that is where you come up with different kind of solutions, gasketing, which you use in cookers. That is a very good example of waterproofing. Well, like gasketing is a very good option. Such application is seen in in the cookers, and so you use gasketing or you use grooves to build some kind of mechanism. Sorry, some kind of structure where there is no water being entered, and you can use such kind of for example these kind of connectors you have to sometimes build by yourself. So these actually allow you to get a waterproofing. So this is a motor controller, and this is an aluminum casing, as I've told, just for the use case of waterproofing. So yeah, it comes down to material properties again, as I told. So yeah, this is more about the motor and motor controller. I'll once again discuss about the motor in brief actually. Yeah, so once again coming back, so this black part, I'll be moving a bit because even so this black part is made with aluminium using casting, and the same way the fins are being provided because you have, like, when you have this, you have airflow coming through this direction and it cools down the motor, and you have windings here and you have different magnets here, and it's windings here. It's a stator part actually. This part is stator part, and you, as I've shown previously, the current enters through this part and this part, and the rotating. So basically, rotating magnetic field is something that if you could see really close to this, really close. These parts are stators, like a lot of, rotors. Small number of plates are laminated here, and you could get this as a single structure. And this thing is a magnet actually. So these are the curve magnets that we use, and these are surface mounted. So as discussed previously, this is a shaft made of EN9 material, hardened again, and this is the flange. So we do close this way. Even this, I would say, this motor is IP67 rated. So we don't have another flange here. So I just wanted to, I just removed it because in order to show the complete motor inside structure of it. And even here, if you could see, we are using an IP67 proofing here. This groove is being put to, like, we do have a groove here. Yeah, so you could see a small groove here. What you do is, the gap between this and this will be having a gasket in order to have a, like, waterproofing, because motors are constantly exposed to air, right? So that is the reason reason for this. And the connectors, you can come across different types of connectors. So this is about motor and motor types and the controller part and all those stuff. So basically, these are made of aluminum again, as I've mentioned, and yeah, casting process is being involved. So I'll just put it down. And as mentioned about this motor controller, so even this is the same thing. So what happens is, the whole control system, how the motor should run, is being made in the form of a circuit board like this. This is actually a BMS, but the motor controller is inside. So the same circuit board, similar kind of circuit board, you build it, write a code, and you have these connectors. Each one, like these two, for example, for terminals, and these are for hall hall sensors, different kind of other throttle sensors, accelerators, and all display and all the stuff. You have to put a wires outside where these connectors are usually used for waterproofing. What you just do is you just connect the counterpart of it. You solder this and create a counterpart of it, creating a complete mating, and proving a complete waterproof for this whole motor and motor controller. So this is where the whole intelligent system is. I'll just keep this aside because I have more to discuss regarding this, which I'll be discussing at the last part. Now let's move on to the batteries. So as I told, controllers and e-axles are for e-axles are for electric four-wheelers. Now let's discuss more about batteries actually. So batteries are something like, there is not much of thing to tell about. So basically, I mean, like the basic thing, you have anode, cathode, and electrolyte, which I'll go to the first this slide actually. So basically, I hope most of you have tried. Most of you had this 1100 Nokia phone where you had an access to remove that rear part, rear casing, and where you can see a pouch-based battery. So these are those pouch-based batteries. It's lithium-ion, and what happens is you do have that small pouch has this whole structure actually. It has both anode, cathode, electrolyte, and separators. So that separates from anode and cathode to have a this thing and other these things as well. So you have, and I'm showing you another type of battery. So I've mentioned you previously about lithium-ion cells. I mean, like I've asked you to imagine it as a remote battery. So this is what the lithium-ion cell looks like. Same as that remote battery, but with a very high power. So this outside surface that you are seeing, this gray color surface, this is just the insulation part. Now this is where the positive terminal is, and this is the negative terminal. So it's as simple as that. I just take a wire out of it, just connect it to the load. This battery starts operating, sending electricity to this way, and the load runs as well. So this is how a lithium-ion cell looks like. Now imagine using these number of cells in a car. You'd be using like thousands of cells stacked together. I'll discuss more about the stacking part a bit later. I have the battery pack with me as well. But this is what the cylindrical cells are. Now I was just showing in the presentation about pouch cells, the one you use in the even today that you use in the mobile phones. You also have the pouch cells. Those don't have high energy density, and so there are, I mean, like, there are a lot of other complications are included as well. These are called cylindrical cells. What cylindrical cells does is, it's the same as anything. You have positive and negative. You just have to stack it in a form of a battery pack, whatever the requirement is, and you are good to go with the load. So whatever the voltage, this each single cell is 3.7 volts. This is called nominal voltage of the cell, and this cell nominal voltage is 3.7, maximum voltage is 4.2 volts. The operating range of voltage is 4.2 volts to 2.9 volts. Now, coming to the point, why I have discussed that this cell requires a electronic system, I'll be sharing it right now, and I'll be discussing. So yeah, as I was saying, like these on the left side you could see cylindrical cells. You have prismatic cells and pouch cells. Pouch cells are usually used in mobile phones. Cylindrical cells usually are used in electric vehicles. Prismatic cells are also even used in that. But these prismatic cells are quite weight, because the whole structure is put in an aluminum kind of an aluminum casing that you put, but this is different application. Even ion. So you could see the third one is lithium. So everything has a lithium in it, but there is also an addition called. So the one I have showed you right now is the third one, lithium ferrum phosphate. These do have less specific energy. What these have is long life, specifically long life, much and long of long life. But the point is, these are much safer. I'll talk about the safety in the last part of it, but I'll tell you, these are one of those cells. It's just like you're playing in a chemistry lab. You have lithium, and you could try with different materials like lithium, nickel, then cobalt, then manganese, then iron phosphates, and magnesium. All those stuff. Each one gives you a different kind of properties. So it all depends on another material. I mean, you could see three materials are being added. Sometimes it's nickel, cobalt, and aluminium. Sometimes it's nickel, cobalt, and magnesium and magnesium. So it can be anything. Depends on your properties and depends on your requirement. You could definitely choose an application, or you could definitely add a material and see this properties. Yeah. So coming to the last two parts of it. So I was discussing about BMS, right? So I was discussing about the safety of the battery, right? So why do we need why do we need the cells to be safer? So we do have two cells operating in remote now, but I'm really worried when I'm connecting another cell to this. How do I why there is a need? That is because we have seen a certain factor here called, you could see under the options, you could see specific energy, specific power, right? Yeah. So those are the two important factors that actually determines the safety of the cells. Large amount of energy is being stored in a small space of cell. So what happens is you're drawing an enormous amount of power. So every material when subjected to continuous treatments or continuous ruptures or friction or anything, it actually loses its properties, or sometimes it actually has thermal runaways also. You know that, like, for example, you're just constantly heating a piece of steel. It actually creates a dent over there or something, because it is losing its property, or it is creating an impact over there. So the same way, these cells, when you're continuously and suddenly drawing power, because in vehicles you draw the power suddenly, right? You're at a traffic. Now suddenly the traffic signal has come, and you have put a throttle and given a sudden rise. So it's like, it is at 0 state, and now you're rising it to 100. I mean, like close to 100 or 70. So there's a steep increase in the power. So that's where this becomes vulnerable. So these are subjected to, lithium, or combined with any other material, are subjected to thermal runaways. These, when drawn more power than the required, what happens is these gets heated up. Your cells also gets heated up, right? So these gets heated up, and they even actually they get fire. So that is called thermal runaway. So this thermal runaway is very much required, because a specific segment of specific person, specific user is using it, life related, safety related issue. I am not sure if you are aware of this news. Like quite a 2 months back or 3 months back, there was a series of vehicles, electric vehicles, that have caught fire. So yeah, if you have known that news, yeah, because of this is the factor. That battery, that is not, I wouldn't blame on the batteries. It might be the standards of the electric circuits that you are using. It might be standards of the battery that you are using, and it might be sometimes you can't blame the manufacturer also. It also comes down to the cell also. Sometimes you never know what is, I mean, like, there is, I'm not saying there is no predictability. There is always a predictability. You can predict each and every individual cell, but it depends on manufacturer to manufacturer. What is the factor that they are really worried about? Is it safety? Is it really performance? Is it performance and being provided with the manufacturer when you're buying a vehicle? So yeah, it's not that it's not predictable. It's completely predictable. You would know each and every minute detail of what is happening. It's between these two positive and negative terminals. So that is the reason you need a thermal management, which is called thermal runaway. And I'm going to switch on the video. I'll explain why more BMS is needed. Yeah. So this is what happens when you. This is what is the difference when you want to build a battery. So this is an individual cell. This is cells stacked together. And if you are able to see this wiring coming out of each and individual this thing, I mean, I just opened the battery. You don't really put the battery in the vehicle in this way. So yeah, so these are the individual cells being monitored. Now this cell is being stacked this way. You do if you can see this black parts of the side and the front in the front here. So this black parts are called battery cell holders. I mean, it's just that you may not specifically have this. This what happens is, here you have positive terminals, here you have negative terminals. There might be a chance of short circuit or like positive and negative being connected. So you use this, and sometimes companies don't use. Sometimes they do have a different technology itself. Sometimes people build a different casing for this. Here, what we have done is individual thing. So what we have done is we have built this thing, designed it, got it injection molded, which is like very mold was quite expensive again, but the individual part is just like comes down to single 1 to 1.5 rupees. This black color part is ABS made of. You must be aware of materials, ABS plastic. So ABS is a good conductor. I mean, like good resistance to heat and electricity. It's a bad insulator to electricity, and it sustains heat until very high temperatures. So that is the reason you use ABS here. It could be any other material depending on the application. So again, if you could see this, I'm just moving it closer to the system. So this thing you could see, this thing is called nickel strip. So there's a nickel strip that is being made to join an individual row. So I'll tell you something. So basically, this individual cell is 3.7 volts and 2.5 ampere hour current. So the voltage of the cell is 3.7, and it can discharge a current of 2.5 amperes, like 2.5 amperes completely. So that is the capacity of the cell, 2.5 amperes per hour. So now what we are building, I hope you have seen our vehicle previously, and the batteries we have shown. So this is a small prototype thing. This is not the one we use in the vehicle. So basically, I want now our system is 58 volts, and our requirement is 15 amps current. So what we do is we stack them in parallel to increase the current. So I have 2.5 amps current. Now I am stacking them in parallel. So my now if I have to remove this whole rows, only one row being there, my voltage would be 3.7 volts, because the voltage across this thing in parallel remains constant. It's only the series, like only the current changes in parallel. So what happens is your current increases here basically. So my battery capacity now is 3.7 volts and 15 amps current. Now, but I have to run it down to completely achieve 58 volts. So now I stack it in series to achieve 58 volts. So that is how the battery packs are made individually. So this big is the battery pack. And this is what I've been showing you past like 10 to 15 minutes. This is the BMS. So this is where the whole battery system lies in. Where like the battery is operated, like certain things like like there are many aspects of it. You could see that individual cells being monitored here. So there's a monitoring system here. There's a complete intelligence system here, basically that actually predicts whenever there is a temperature increase. There's certain sensors. There are certain two sensors here, which actually detects the thermal part of it. So I mean the battery temperature and all. So these are the factors that you basically around, and the electronic circuit is needed because of that. So yeah, first I'll finish it. I'll finish one more slide, and then I'll show you. Then I'll discuss about the last part of it.
Hello. Anna, any queries?
No. I randomly put. I mean, like couldn't.
Okay, sure.
Okay. So the last part of it, digital twin. So this is something very interesting. First I'll finish it off and I'll show you a few other things as well. So basically, digital twin is when I told you that we could play the hardware with the software. So this is where the technology that we've built. So it's basically you are connecting the hardware to your software, and you could change what are the factors that you have. What are the factors that we have in control? So that those things can be changed. So this is the most interesting part of it, because this features the most tech features of it. So you would know everything that's happening with the vehicle. I mean, as I told, we won't be informing the user about there's a potential there is a potential damage in the cell, but we would be informing the user in different way. We're telling that there is a change in the battery health. We would ask the user to shut it down for a moment, or we would initially see what is happening with the way individual cells or the batteries in the here system here. Like for example, I'm sitting here in my office and someone in like somewhere a random place bought the vehicle, and where they don't have a service station. So that's where I could. I mean, as I told in the first of my sessions, as long as it's not a physical damage, we would be sitting here and solving out the problem there. So that is one thing, and second thing would be uh, uh, yeah, so it actually predicts the failure. So it's more of a machine learning and an AI, artificial intelligence. So I wouldn't say much of a higher artificial intelligence. We are in an advanced stage of machine learning. We couldn't. I mean, like we are still developing. More and more amount of data can really help us to achieve that good amount of predictability with the safety systems. So that is the reason we offer uh, keeping. I mean, like the technology is where could help you to offer customers in a more safer batteries and safer systems, and helps you to have a cool, better technology. You could play with the system. As I told, you can just tune the hardware just like you're playing a video game. So that is how this technology is behind the EVs are. So that ends my presentation. But I'll just finish off few other components that I actually wanted to show you. Then that ends the complete session as well. So I've been discussing about. I'll turn more into mechanical system now. I've shown you a battery, voltage, BMS, electronic circuits, and all, and also I've discussed about motor controller casing. Now this is the battery casing actually. So this is made of aluminium. I'll just give you a small example how we started this product design. I mean, there are a lot of components. The reason why I'm discussing this is this will give you an idea on a product development, and the reason why I'm saying product development is it's not to focus more on the product, but also to make you understand that whatever see to understand that whatever currently you are studying or currently you are learning in the classes is it will help you to design such kind of products. And I'll tell you because I've been I've done quite good in few of the subjects, but not much in production technology, because I always felt much of a theory couldn't really like knowing that and kind of sometimes you have to imagine those processes which is like when you can't see that it's sometimes for different kind of people it's hard to imagine. So that's where I would say the importance. I had to really understand. Whenever you are designing in your CAD or whenever you are designing in anything. So how exactly would you design? Well, let's start with this small breakdown analysis for this. So I'll do one thing. I'll just put this way. I hope you're seeing the pattern. This is much better. So I'll just do the breakdown analysis. So this is two sides open. This is where we put that whole battery with foam around it. So that even aluminium, though it has a good heat transfer, at higher temperatures, it also allows the heat inside, which might be a critical factor for the battery. So we use a we use a different kind of foam, not the foams that we get it with this thing. It's an SLU foam. So that foam allows us to. Sorry. So that foam allows us to reduce the interaction between the heat transfer of aluminium, the heat of aluminium to touch the batteries. So that is one thing. But let's go ahead with this product development. Like for example, the first point comes down to is like I have a product to design. So which is like I have to design a case for the batteries. So if I have to design a case for the batteries, my first question would be, batteries are first part is batteries are, as I told, something that involves electric currents. So the first thing I have to choose would be a non-conductive material, an insulative materials. So now my first analysis is when I have to design this battery case, first question would be my material. So I have like done number of materials, right? Now for my first thing is I have lot of as I've shown you the battery pack, you know the predetermined shape. It's a cuboid. So I know that my rectangular case my case has to be cuboid or somewhere around it to avoid a lot of space constraints or a lot of material waste, right? So my second thing is I have numerous number of materials. But first I'll list down materials. What materials do I use to manufacture? What materials does have manufacturability? And also breaking it down, what manufacturers I do have. I mean, this part which is not involved much in a educational point of view, but I'll tell you even this could be a good example. So with numerous number of materials, I've cut down in a different way. Like I've now made materials that are only manufacturable in my constraints. Second step is I have cut down the materials where I can found the manufacturers. Now the third step is I need this desired shape. What is that another factors that I do need to have? Because when I told batteries are subjected to high vulnerability in different cases. and the heat from the battery has to be transferred. First eliminates the major material, which is steel. Steel cannot do my heat transfer. Even though it does, though it is higher in weight. And my battery can't be higher in weight because I have to remove that battery and carry it with me. I can't put a 3 mm sheet metal and ask the user to carry it, which is like very heavy. It's like 7,800 per kg per meter cube. Which would be around, if I have to make a case for such kind of battery, it would be something around 4.2 kgs or something. So that big. I am not asking my user to carry 4.2 kgs, just only the battery case. There's a battery, there's a BMS, there's a connector, and all the stuff. So steel is out of my way. Now comes down to titanium, platinum, and a few type platinum material. But again, platinum is very expensive. Do I really need? Do I have to afford that? No, absolutely, because I have to give it to the user. So it comes down to shortens my material of like aluminium and plastic. Now plastic doesn't have much of a heat transfer rate. Now plastic, if I have to go, it has to be an injection molding, the process that involves making of a plastic. It's a good process. It's an easy process because now I'm not using injection molding because I have one and both the sides open. So when I have both the sides open, I can open up a new process now, which is called pull extrusion. So I have cut down my process to both the things: injection molding, pull extrusion for plastic. Again, I can pull extrude aluminum as well. So casting and pull extrusion for aluminum. So I have two materials left, two processes left. So now I have to choose between which one is better. As I told, plastic could be a good solution because bad conductor of electricity. Aluminum as well. And second thing is plastic density is quite less. Now here comes my point. Because plastic has an edge. Because plastic density is less and the overall battery weight would be less. But does really aluminum? What happens? What happens with aluminum is it has good transfer rate, heat transfer rate, and you could use a lesser thickness and use a different kind of manufacturing processes. Now, what I have done is, as I've told before, this is just a small breakdown, and I'm like I am not. If I have to invest casting, if I have to invest in casting for this piece, would cost me around like at least 2 to 2.5 lakhs for the mold. An individual piece would cost me around like hardly 120 bucks. Same with the pultrusion, but pultrusion costs little less, like 1.2 lakhs for the mold, and the same 100 or 120 bucks for the case. So as I told, as a startup, we couldn't really afford that. But like pultrusion is something we could afford, but we found another way. What we have done is took a flat sheet of aluminum plate, you cut it into the required dimensions, then use a CNC bending machine to get this U shape. This U, I would say, you could see this. This U, we could get it. And what we have done is, this top sheet, what we have done is, we have cut this sheet from a CNC laser cutting, and you could see the welding here. So we have welded it on top of it. Given that my battery does not have any heavy structural loads, and with aluminum having a very good properties, I could rely on this welding. And obviously, what I have to weld it on two sides because my waterproofing has to be done. So this is how we build the battery cases using aluminum. So yeah, so this is just a breakdown analysis of how you build a product. The reason why I've involved much of technical stuff, I mean like much of manufacturing related is, so this is how you use your subjects to really build a product. So see, it might sound that, I mean, like I've been discussing this. It might sound that I'm using more of subjects. Trust me, I'm not really in the top or that kind of stuff. I really try to understand the subject as much as possible. The reason why I'm trying to stress out this point is, I've mentioned this point before. I've never really, I've never been into this production technology before. I mean, like even though in the classes, I could really miss out on few points, not able to really catch up because I couldn't really imagine. But what I'm trying to tell is that really created me a problem. Obviously, even now I have to really understand each and every stuff before, it does not only help you to build a product. I mean, it does not help you to make a decision, or for example, uh, if you know only quite a few processes, you would miss out on a lot of things. Like for example, I could have, if I'm not sure of pull extrusion, I would have missed out on. I mean, I would have spent lakhs and lakhs on casting. If I wouldn't have known about sheet metal bending, I mean like CNC sheet metal bending, I would have missed out on. I would have spent another 1 lakh or 2 lakhs on this extrusion part. So all now is like I have a case that cost me around 200 bucks, but I have a small increase in the per unit cost. But what I can do is, for now, until I find a proper solution, until I find a proper manufacturer, until I have enough resources and funds, I could easily do it with this such kind of casings. So that is how I relate my learnings from the classes to the final things that we are doing now. It is really helpful. That actually gives you a basics of it, and also I try to give you more and more of how do you build a product. That is how you break down the product. I've just involved more of a subject basis stuff. You also involve stresses around it. You're building a cap. You're building a waterproof thing. What are the groovings that you design? What are the, what do you call it? What are the waterproofing things like I completely forgot the word. Yeah, so that you could design. So these are the things. Basically, these are the things that help you to understand and break down a complete product build. So this is my approach. I usually start from basics. I see the application. I cut down the basic requirements. Then I start with the design of the product. Then I dig deep into materials, manufacturing process, design for manufacturing, manufacturability. Then again, I have like strength after manufacturing, post processing of manufacturing this components. So all this needs to be analyzed, for which you need to have a basics in depth of a complete subject knowledge. And yeah, so that is about battery casings, motor controller casings, batteries, lithium-ion batteries, motors, and motor controllers. So I hope I've made few things clear about the batteries and motors. I really didn't want to dig deep into the electrical part of it. But what I suggest is I suggest you to start from now. Though I will tell you one major thing actually. So being in a mechanical department, one advantage that you would have is you would have an overall touch about the other subjects as well. You're building a circuit. You know the basic circuit that you could build with this thing, and the material properties as well. You could involve in different kind of designs and all. So what I'm trying to tell you is, you need to have at least basic knowledge of all this stuff to take it to the industrial level as well. So this ends my electric vehicles presentation. So finally, I just would like to say, I'll just brief it in a small, like 4-5 minutes thing, that electric vehicles. The shift, the first part we have discussed, I would say, is the shift in electric vehicles. So why there is a need for shift? I wouldn't say. I mean, like much of the points involved technical aspects like energy consumption, like involving engines and drive shafts and all, but also environmental aspects as well. And second thing is you could really drive a energy efficient vehicle. All now we are driving is a like internal combustion engines is like 30 hardly 30% efficient vehicles. You could use a cleaner energy, and the point is economical as well. So I won't mention this as in terms of I won't stress this point, but these are the most economic ways. So there might be a solution in the future. I'm not putting it down, but economical ways. And then we have learned about how we slowly transition from engine-based vehicles to electric vehicles with hybrid vehicles in between. And now we know that what effects that engine have on a frame structure. and what effects that an electric motor have on a frame structure. Then you have battery packs, then you have frame structures, then you have drive systems that we have discussed, BMS, battery management system, motor controllers, and finally digital twin, IoT part of the technology. So this is what, digital twin, I would say, is a new trend in the EVs. Not much of manufacturers really do that. All it depends on how will you want your user to know about your vehicle. That is one thing. And one another interesting aspect a future trend that I was discussing was hydrogen-based vehicles, skateboard-based platform, EV platform, four-wheeler platform, and also aluminium chassis or a monocoque chassis. These are real game changers actually in the future. So we are talking a lot. We have talked enough about, steel-based vehicles and all. This is the time to shift to aluminium, or this is the time to shift to new different types of materials or different types of frame designs. You know, you know. So that has been the story with the EVs. I see it as a challenge. Though I'm saying frames has to be innovated, frame part has to be innovated. I still see it as a challenge in India to be adaptable. I'll tell you a small example. Just give me a second. So I hope you have seen the second frame that I've shown you. So yeah, this electric vehicle you could see here. You could see it's a kind of a bare body. Now what? See, I'll tell you the main intention of our building this kind of a vehicle is. One is that we actually want to come up with a different frame design, like something that could create a fun factor. That could have a good rigidity, that could have good frame structural properties, but still give you a good frame design. So that is how we have come up with a concept of retro. You could see these vehicles, and we have sold good number of vehicles in the market, but less in Telangana. I don't know, the adaptability has been very much low here. Bangalore and Mumbai has been really great. But yeah, I would say, our main intention was to give a different look to the vehicle and different concept to it. Create a fun factor around it. It's not like, I just wanted to go like, this is neither a bicycle, nor a motorcycle, nor a scooter design, nor a moped. You couldn't really put this into any junction of vehicle or any segment of vehicles. So that is how we have come up with. I'm not saying like this has to be the thing, but we found it really hard to adapt. Really hard to adapt. No, we thought this design could really make a change. It really did. It really did, because we don't have an physical outlet yet. All the sales have been through online only, but still we could make a real good impact with this design. And everyone who bought our vehicle was really only focused on the design part of it. It's actually a retro design of it. And yeah, so that's how we have built this model. But adaptability has been very less. But Europe has been a great market for it. This month of May of 2022, we are starting exporting it to the European market of a very thousands of volumes, because the adaptability there has been really great. So that is the I wouldn't say the difference. It always been a different kind of this thing. So when I was focusing more on frames, so this is one kind of thing that we have designed. And I'd like to go to the second model, which we haven't released yet. So this model, probably no clarity in the picture here. Yeah, but this is even this neither comes into the scooty version as well. We have come up with a different unique design and a very sleek design, which is made of completely aluminium. So we are coming up with a two-seater version of this in the month of March. So we are currently in the final phase of production. But yeah, whatever we try to do is always, as I told, this is our motto finally. So we wanted to give a good unique technology. I'm not saying a unique technology. I just want to serve the purpose of the user in a different way, and with design and fun as the two other factors that I would say. So yeah, so I would say yeah, there ends my presentation and complete feedback. I mean, like complete brief on electric vehicles and what we do. Any questions you could just throw it at us. Thank you. And thank you, sir, Rana sir, and Vinod sir, and Anil Kumar sir for giving me this opportunity. It's good to interact with good number of people here. Good to share my knowledge, and I would always I'm open to come to college anytime, whenever things are proper. Given that COVID thing, I would be really happy to bring my vehicles and show you a complete breakdown of how the analysis, and even I could bring my team to have a complete tour of like the whole motors, batteries, manufacturing, and all those stuff as well. It's always good to interact with people and take their ideas. And thank you, Rana sir, once again for giving me this opportunity. And thanks, Satvik, for coordinating with me smoothly. This has been a real good thing. Thank you once again.
Yeah, thank you so much, Anna, for your continuous explanation of all the things with from very scratch, we would say. And I would over this to Jafar. Okay. I want students to please give feedback uh, on the entire workshop, what you have experienced. Guys, please raise your hands so that, yeah. Yeah, 212L, you can speak.
Sir, greetings, sir.
Sir, friend, just a minute. So before speaking, please on your video. Please on your video and speak. Right. Thank you.
So, good evening, sir. Actually, first of all, I want to thank my coordinator Satvik Khanna for organizing this the best workshop, and I thank every faculty and our HOD sir because we only know the outcome of the electric vehicle, but we have learned how that electric vehicle works and how we can use it as mechanical engineer or any branch. This have helped me a lot, sir, and I thank. And next I thank my Harsha brother. He has taken a great time to us, and sir Vinod sir and Hari and next all my faculty. Sir, thank you, sir, because you have given a great platform to us to learn and to explore ourselves. And I really thank each of my friends for participating in this and getting. So thank you, sir, for this event.
Yeah. One more 008. Are you there? Guys, please raise your hand so that we'll give access to speak. I've seen 3 to 4 people have raised their hands. Guys,
Good
please
afternoon,
come
sir.
forward. Okay.
Good afternoon, sir. I thank HOD sir for conducting this workshop, and it gives us immense pleasure to have this workshop. And I thank Harsha bro for conducting this workshop and taking time for us for having 2 sessions in his busy schedule. I thank him for the knowledge he have, and I'm very lucky to be part in this workshop because I learned many new things regarding the frames and the role of CG in two-wheelers and four-wheelers, and the new term called modular frame and the effectiveness of a modular frame, and the breakdown up the approach he have using breakdown analysis and the constraints he faced during his production phase. It gives me it gives a different experience for me while thinking about a startup, and I thank him for this for giving this opportunity. Thank you.
Yeah, it's a great words from you, and we could see your experience completely what you have gained. And next, guys, please come forward. Yeah, Jafar, continue.
Good evening, sir. Good evening, one and all. Hello, sir. Am I audible, sir? Hello. Yeah, good evening, sir. Good evening, one and all. First of all, I would like to thank our Harsha bro, our product, for giving us all the valuable inputs what we have been through this session. He had explained us very clearly about the current scenario and describing us about in details about the electric vehicle, its current scenario, how it differs from a normal IC engine and how an electric vehicle, and the difference between them is clearly mentioned in this session. Like its moving parts, how its weight ratio is also to be considered, and its efficiency, like from the normal IC engines, how an electric vehicle differs, its efficiency, and coming about the classifications. He gave us detailed classifications about the electric vehicles, like what are hybrid vehicles, electric vehicles, plug-in hybrid vehicles, what are the latest technologies we have been the world has been going through. We came aware about all these in this session specially. And then next step, coming to the electric motors, the main component of the electric vehicle, which is the motor, electric vehicle motor. What are its types, and its internal working mechanism. All we have been through was very informative. I thank you so much, Harshana, for giving us these valuable inputs, and I really enjoyed the session. I learned a lot from this session. Thank you.
Really good to hear those things. Yeah, thank you so much.
Guys, still anyone? Guys, please come forward. You can share or any doubts, whatever you have, or if you need any help regarding this electric vehicle, or you need any real world experience, or whatever the thing you have, please share. I think this is the best platform, guys. Come out of the world you're in. Okay, once again, 212L.
So again, after reopening our college, sir, we want a hand-to-hand interaction with brother, sir. It's my request.
We will definitely plan it, and with the instructions of head of the department and our faculty in charge, we'll definitely plan it. And we assure you, we will be back very soon. And I also request faculty to speak a few words.
Yeah,
Thank you, Harsha. In the meantime, can you educate our student community? What are the challenges you have faced during the evolution process, and how could you overcome it?
Definitely, sir. Yeah. So as I was saying, like it's really. I mean, like back in 2019, it was really hard. I mean, these days we see many startups getting funded. But yeah, back in 2019, it was like 2018 at the end where we thought that we'd start this, and the research was started back in 2018 January itself. So how do we really proceed and all? So it's just that it's really challenging to build something from scratch. The point is, like we have made up our mind first of all. So whatever we'll be doing, we will be manufacturing by ourselves. We'll be building components by ourselves. So I would say, like there's certain components, like even lights or certain components, even that we managed to build by ourselves to try to cut down the cost. Then again, to give a unique designs to it, not something that's always available in the market. So that was our motto when we started. And the point was, like, I was the one here dealing with, and my brother is another co-founder. He is actually based out of US. So he does the electronics designs and all. But there was a lot of this thing. But again, yeah, we could really manage. We could really build out a complete vehicle out of it. And I would, on this occasion, I know I don't have my teammates here, but I would say, like without them, it has been a great support from them. Uh, you could say, like, one of our alumni and my junior, Shiva Prasad. So he's been the key part in our development of this company right from scratch. So he was on who stood behind us. And yeah, so as I tell, like, even today, you need not have a company or a company name or something to do or build an idea. So you could just build it. I mean, what my suggestion is, just don't wait for something to happen. Like whatever you are trying to do on a day-to-day basis, just try to find out what exactly is. See, it need not solve a problem always. See, for example, I hope you are aware of very much recent news, like Zomato have taken its IPO, initial public offering, like gone into stock market, so public shares. So I'll just give you a small example. What exactly is Zomato? Zomato is nothing that you just have. It's just that, well, if you really have to take the COVID out of the equation, Zomato is like just like nothing. Like it's bringing your food to here. I'm just saying that small idea is $1 billion company now. So it could be anything. It need not be a problem solver. It could be a luxury. It could be a luxury. What is Nika? I hope women, ladies out of here, like, would definitely know about Nika. Nika has its own IPO right now, and which is worth like 16,000 crores something. So I would say, like it's just a beauty brand or something. I mean, I'm saying it's a luxury brand. So what I'm trying to tell here is, it need not solve a problem all the time. It can give a good unique product out of it. Like it can be a unique product. It could be just a luxury product. What it's how it's just a difference between Apple what exactly it provides. You could definitely tell a privacy feature, but I would definitely doubt that. But yeah, but Apple is Apple, that. See, again, I you might think that I've been telling only a great companies that have come, that has already profited, or that has already have $1 billion markets or something. uh, there are many companies. I've been part of T-Hub, where you can sit and work. Or you work. That's a incubation cell. So where you can sit and work, and you get few support from the government, you get support from the investors and all. So that place, I've seen many startups grow. I've seen many startups grow into different very valuable $1 million companies. So it need not be anything. It could be a basic problem solver. So companies you might not heard of, but I know a company that raised 500 crores that just sits behind me. So yeah, so I would say like $69 million. That's something that they have raised very recently. So yeah, I'm not saying that only like I'm not taking examples of $1 billion companies and quoting out. It's just that you have to stick to the idea. It's I agree. This point of time, we definitely want to have a good thing in the college and all. So what I suggest is stick to the basics again all the time. That is my suggestion. That is my preferred methodology every time I follow. But you could develop your own. Just start work. Just start seeing around you, and you never know. You might build a app or a product or out of nowhere. It could be out of anywhere. Like so, yeah. So that is my suggestion. And don't worry about the consequences. I mean, like don't worry about the complications. Obviously, nothing comes free. We all talk about a lot of stories, successful stories, and all, right? So Paytm, we talk about Paytm founder being, having a salary of 4,000. And I'll put you this story again. I have I when I started, I had a good offer from Cyient and Mahindra R&D auto division. But I always wanted to learn in a place where I like where there is a constant learning and thriving. So my starting salary when I was in Bangalore was just 9,000, and in a place like Bangalore it was really tough. So and that made me a good person, actually, I would say. So these are the challenges that you usually face in life. I mean, that is very simple. And even in when you want to have a startup, when you want to start a new thing, when you want to build on your idea, there are challenges, absolutely challenges. Nothing comes free. You will definitely succeed. That is my only info. I mean, like that is my only thing to you. You start working on it, and also just don't take me wrong again. You just really need to focus on the subjects. It's for the future use. Definitely, you could get very much basics out of it. Even if you really want to continue in a core mechanical, want to be a core mechanical designer or automobile designer, aerospace, everything involves a lot of complexities. So yeah, just focus on it. Just try to learn as much as possible. So yeah, that's it. Any questions, you could always connect me on LinkedIn, or you could just text me over WhatsApp. I'll be if I'm not able to reply at some time, but definitely I'll be available at some point of time. LinkedIn would be a good platform, I would say. Yeah.
Yeah, that's awesome, Harsha. Thank you for wonderful insights. Right, we are really enjoying right your session and the way you have grown.
Thank you, sir. Thank you so much.
If possible, what are the productive habits you have developed over a period of time? Can you please present so that other people can adopt?
Yeah, see, I mean, like, this would be a flat good thing. Yeah, I haven't really. I had a habit of reading books right from my this thing, so which I continued. But lately, it's always been like I used to watch a lot of this Netflix and these things back when I was working. But when you are really working on your idea, nothing comes into your way. Sometimes you really don't get a time even to watch those things. So yeah, I think the only thing I really kept in constant with me was reading good books. My suggestion is like I always go back to storybooks in childhood. The storybooks I read, because that helps me being imaginative, bring back those imaginative things, which I could really apply to my products as well. I mean, like, helps me to really think deep, and yeah, that's how I've been following. But yeah, that is one thing I constantly do. Nothing much.
Yeah, fantastic, Harsha. The way you are portraying, really amazing. Yeah, in any semester, normally people reads 3 to or 6 or 8 courses. But during your presentation, whatever is the topic you are referring it to very deeper level, and the understanding of the topic is very unique from your tip. So you are speaking in terms of materials, design for manufacturability, design strategies, and manufacturing strategies, and picking up the right method for your desired shape. So you could able to focus on electrical aspects, and you could able to project on even in terms of user requirement. How could you handle all these? How could you gain all such a elaborate thought process in various allied areas just during these simple 3 to 4 years? Of course, in the even 3 to 4 years, almost 2 years went in pandemic. What happened? What is the miracle happened in your life? I'm sorry, your voice is not audible.
Yeah. So I wouldn't say it as a miracle again. So it's just that, I've basically kept that thing, I still remember those days back in 2013 when I joined college. I was really amazed with I still tell people because of the faculty that we have, and I could really learn. It has been a very good experience there, and that formed me a complete base, I would say. The support that the faculty has provided in building as a car, and constantly providing that support, that really helped me in a good way, and that formed the base, I would say. And again, with working 2 years again in a startup, heading the technology there, I had to constantly keep updated about different types of manufacturabilities and designs and all. That back in 2018 when I had a plan to have the startup, that's where I was constantly using my time really to understand different types of manufacturings. I used to visit a lot of manufacturing facilities over when I was back in Bangalore and Chennai. For the company that I used to be part of. So that's where, the only thing I would say is I would say every single time I really have that thing to learn every time. I still wanted to learn different technologies. I really want to work on different technologies. Being a mechanical engineer right now, I would say I have started to code as well. So that came only with my interest in learning, and sometimes it has been a different external aspects as well. Sometimes where I had to depend on someone else for some kind of designs or electrical features or coding related stuff. I had to really, when I couldn't get much help, I had to really learn myself. The same goes with the manufacturing thing and the mechanical aspects that I've got it. And I would still remember I really want to make that point. And I hope that technology entrepreneurship program is really continuing in the college. That also gave me a complete different perspective in thinking and breaking down the analysis of how exactly we approach to a problem. So yeah, it's always problem solving thing that really helped me. Interest in solving this challenging problems, that actually helped me to gain, I would say, good amount. Whatever the knowledge that I could gain.
Good, Harsha. So last point, can you throw some light about your organization name?
Yes, sir. So I've mentioned earlier, it's Uton Energia. So it's utility and energy, something as I've mentioned, like utility of electric vehicles is something that we actually wanted to focus on, energy consumption and all. So that's how we have come up with the name Uton Energia. And we have released our first product back in February 2021 called 45, the first frame that I've shown. And we are launching a couple of products in the month of March and May. And with May, we will be one of few companies in India exporting to the European market, global markets.
So why it was chosen 45? Can you please educate?
Yes, sir, definitely. Actually, so when we try to build that kind of structure, so we came up with a very vague design. Then we slowly optimized and made it like as optimizable as we could. And what came out of that optimization was the wheelbase, the seat height, I mean the handle height. I mean few other geometrical dimensions have been 45 inches. And I would say other thing is when we told that we have built a retro vehicle, so we have used that we have made a retro design and used futuristic technology. So what we have done is we have four components or four features in the vehicle that have a retro features and five futuristic features. So it all combined together to get into this 45 number.
Amazing, amazing. You're happy to interact with you, Harsha.
Thank you, Harsha, bro. Thank you so much for giving the valuable insight and how you showed us, in spite of the difficulties, you stood strong and stood focused on your own idea, and you are here still. We are so happy for you. Thank you so much. Now I request Sri S. Anil Kumar sir to give a few words on this.
Sir, you're in mute, sir.
Thank you, Harsha. Thank you for giving the brief introduction, brief about the electrical vehicles. I want to ask one question, sir. Just Harsha.
Yeah.
We are having a lab, ICE engines lab is there. I am in charge for the internal ICE engines lab.
Sure.
Do you have any testing procedures for electrical vehicles?
Yes, sir. We do have a testing and validation for the electric vehicles, sir.
Can we establish one equipment in our lab?
Definitely, sir. Definitely.
Because,
so basically, there are certain standards. Actually, we have built our own testing machines, and we have got approved by ARI certification. So
yes.
yeah, because so far there was no standard testing machines. So to build to test out our batteries and motors, we have built a standard testing machine, and with the approval, we have got the approval as well. I could share the details over the mail or something. You could see and definitely give me a feedback on it. I will definitely try to improve and establish it on the lab.
Okay. Because we are next changing from curriculum to the URA 22. In that we have to include these because we are coming to the conventional to the new technologies. That is the way we are changing from the conventional to the electrical battery vehicles. That is the way I am asking the question to you.
Definitely,
thank
sir.
you.
I would really...
if because we are dealing with Ramesh sir as well as Vinod sir, myself are dealing with BTech 6th semester as a internal combustion engines and gas turbines. For that purpose, we will meet you in your Utan Energy in Hyderabad in coming days. Okay, after contacting you, and I again from other students already asking about physical mode. Whenever we are opening our college, we will interact you once again. Thank you, Harsha. Thank you for giving opportunity. And finally, I thank to the Satvik, student coordinator, and Jafar, Vidhi, and uh, and for students participants. I hope you are enjoying this workshop with this. And the next year we are going for the new technologies. You can observe that what are the new technologies, how we are changing from 2014 to 2022. I have already listed from ICE engines. 2014 we are conducted ICE engines. Now we are conducting electrical vehicles. How the transformation takes place from in the today's life. Okay. Thank you for giving opportunity for the head of the department, sir. Sir, thank you, sir. Over to you. Jafar, over to you.
Sir, thank you so much, sir. Sir, surely with your efforts and under our management guidance, we'll surely come up. We will nourish, sir. Thank you so much, sir. Sir, and now I request Sri G. Vinod Kumar, sir, to speak a few words on this.
So, thank you, Jafar. So, friends, so I am going to summarize the lecture, the session, morning session and the evening session, right? So in morning session, we have started with defining an electrical vehicle and then classifying the electrical vehicles, that is autonomous, hybrid system, and what is the difference between the regular internal combustion engines, electrical vehicles. Harsha also explained about the components and how the efficiency varies. And in order to increase the efficiency, in regular IC engines, we go with the mass system, right? But while coming to the electrical engines, if we can compromise at the weight, right? So significance of weight is also been explained very nicely by the Harsha, because each and every component. So he explained how many parts are available in internal combustion engines, what is the weight of the transmission system, and how many number of components we are eliminating by making use of this electrical engine. So here we will be able to establish the real significance of the weight on the performance. So that was been very nicely explained by Harsha, and using in your diagrams, those are very encouraging. And next, the alignment, battery alignment, where we can align the battery. He also explained about the control system, and along with that, as Rana sir has explained, he is putting wherever there is a possibility, he is explaining the each and every significant parameter, like material significance also. Why we are going for aluminum casings, and why we are going for a ceramic materials or any other materials, right? So material significance is also been explained very nicely by Harsha. And while coming to the second session, so started from the structure, different types of structures like frameworks. In frameworks, he explained the tubular frame, aluminum frame. So aluminum frame using casting, modular frame for a four-wheeler, and he also explained the vibration damping mechanisms, and also the significance of center of gravity. So how center of gravity is also going to influence into two-wheelers as well as the four-wheelers, where this more number of stresses are going to take place in a tubular frame. So all these have been explained very nicely. And during our live demonstration, he has shown the motor which is used in our electrical vehicle. He also shown the battery, right? And battery management system. He explained battery management system in a live condition. That is also very beautiful. And explained along with the battery management system, he also explained the significance of efficiency and safety. On which parameter we must select a battery management system. And battery stacking. So each and every cell, if we try to connect in parallel and series combination, then that is going to form a battery bank. And he also explained about BMS, that is battery maintenance or monitoring system. And the last and the important, he highlighted about the digital twin, which is interaction between the hardware and the software. And finally, the most research areas in electrical vehicles. So material, structure, battery management system, how to improve the efficiency. So thank you, Harsha, for really providing each and every minute thing, starting from A to Z. We can say it is an A to Z of an electrical vehicle system. And friends, one more thing I want to make it clear here. Actually, we planned physically, and Harsha has promised us that he will be bringing the physical models which he has designed, and he promised that he will be demonstrating each and everything by assembly. And we assure that we will definitely conduct one more program, not as a part of Sumshodhini, but as a part of MESA. We will definitely conduct. We will call Harsha. We will have a full-fledged hands-off experience session. Right? So thank you for giving me the opportunity. Thank you, Rana sir, and thank you, Satvik and team, for cooperating with me. Thank you, Sumitra, Anil, and all other senior faculty members for providing their suggestions. Thank you all. Over to you, Jafar.
So thank you, sir. That was wonderful and very informative feedback. And now I request Vidhi Sirvi to deliver her vote of thanks for this successful conduction of workshop. Over to you, Vidhi.
Thank you, Zafar. Very good evening to all. It gives me immense pleasure to deliver the vote of thanks for this event and to all the dignitaries assembled here. First of all, I would like to thank our chief guest and our proud alumnus, Harshavardhan sir, for valuable inputs and that are all delivered. And now I would like to thank our beloved principal, Dr. K. Ashoka Reddy sir, professor and head of department, Dr. K. Rajanarendra Reddy sir, faculty coordinators, student coordinator, student organizers, IST, technical club, MESA and PMC, and most importantly, the participated students for this workshop that made this event a grand success. Thank you.
Yes. Yes.
Friends, last one, if possible, if all of you please on your videos, you will have a screenshot and we will exit from the meeting.
Yes. I request all the participants to please put on your video so that we'll have a snap.
Thank you. Thank you. I also request Harsha to on the video. So Anil and Sumitra are also requested to on their videos. So Satvik, okay na? Harsha annada?
Yes, sir. Sir, I thank head of the department and all the faculty for sir. Thank you so much. Sir, with your permission, we'll end this meeting. Rana sir.
Okay, thank you all.
And last but not least, let us all cheer for ourselves for this successful conduction of the workshop. Thank you all.